Good morning and welcome to this week's CoE-MaSS seminar. Our speaker this morning is Professor Sibusiso Moyo. She is currently Deputy Vice Chancellor at the University of Stellenbosch, and she leads research, innovation, and postgraduate studies. She holds a PhD in mathematics from the University of Durban, with specialization in optimization and differential equations. She also has a master's degree in tertiary education management from Martins Institute. And I see that it is the latter part of the latter degree that is coming into play now with the illustrious role as BBC. We welcome our speaker.
Thank you so much for the introduction. Can I just confirm if you can hear me from your side?
Yes, we can hear you perfectly.
Okay, great. Thank you so much. So I'm going to, first of all, I think because I must make two apologies. The first one is the title of the that was sent through my office. So I will focus on the title, and then I think the content was slightly different from the title that was given. So when I was working through, I thought, okay, I will adjust it a bit. So there might be, I will not have equations to show you, but I will talk about generally what the topic says. And then the other thing is really, if you have questions, feel free to ask. But before then, I thought that I might forget to do this, so I really need to make an announcement. And tell me if you can. I'm going to try to share, first of all, my screen. This is screen one. I hope that works. Because I want, so I'm sharing my entire screen. So I'm gonna share that. And then if you can tell me whether you can see a list of workshops on your screen. Are you able to see that as well?
Yes.
Okay, so the first thing I want to start with, in case I forget, is that, so you see, if you go to the American Mathematical Society, you see that there's a list of workshops which are given for the whole year. And I just want to bring your attention to the workshop which is taking place in Stellenbosch on the 19th of November, 2025. And it is on dynamical systems, theory and modeling, and of course, AI. We tried to be, to accommodate broader fields as part of that. But I think this workshop talks to the work that we are trying to do around, promoting interdisciplinary studies, but interdisciplinary research, but also trying to bring people from different fields together, to work on interesting problems, and also to look at the developments which are happening, especially within, recent developments within the AI area. So I just bring this to your attention, and you can find this on the website, AMS website, and if you go to meetings, and under meetings, you'll find that. So I'll stop sharing this if that's okay. And also, I think what is good with this website is that if you are thinking of, what can I participate in, it's a more reliable, list of meetings that probably make sense. We get a lot of information these days from different sources. And I think if you are an emerging researcher, it can be quite difficult to know which conferences are reliable, which workshops aligned to your field, what makes sense. So I think this one is a bit more reliable. So I'll stop sharing that for now. And then I will then go, hopefully I can get into my presentation, and then I will start by introducing myself once I share. Let me just make sure I'm on the right screen. We're gonna start from here. No, not a new slide, sorry about that. I want to start from the beginning. So I should go here, slideshow, but it should go to the beginning. Okay, cool. All right. So I was given this topic that, we are supposed to go through. Again, as I said, feel free to, to ask if you have questions. It's the role of mathematical sciences as a catalyst for advancing skills training in the science, technology, innovation areas and meeting developmental and technological goals. And I've been introduced. So I don't want to talk about my PhD because it was several years ago. I feel like really old at this stage, but in any case, I did my PhD on differential equations and mainly using group theoretical methods in terms of finding solutions. And then over the years, of course, I've been able to work with people from different fields and apply this, especially to the areas in mathematical physics, some engineers, and then people in health as well, and some people working also in computer science. So I've been able to also expand my interests beyond just the theoretical part. So we know that within the South African context, for example, if we talk about maths, I noticed that we still have a lot of discussions around, the complexity and inequality around, maths performance. So South African schools, maths results in this quotation, it says that, what explains the low scores of children in a country with world-class universities? And I think we've done fairly well over the years in terms of maths performance. I mean, in universities, promoting maths and making sure there's more access. But we know that there's inequality in different schools. So it's not the same. The experience that one may have in a very well-resourced space is not the same. And even in universities, it's not the same. I'll talk a little bit about that from the experience that we've had, also getting, master's and doctoral students who are trained also differently. So according to this quote, which I found on the UNESCO website, it says that the cause is partly attributed to the lack of qualified maths teachers and the effects of past segregation policies. This is in the South African context. And then it is proposed, of course, that to reverse this negative trend, maths education should be reinforced from the very first, from early, ages. That's from the very first grade. And I think Jonathan Jansen, who's based at Stellenbosch University, has also written quite a bit about this. So I wanted to just mention this to give a context within the South African context, and also to kind of put the topic, why this topic is important for us to look at today. And then I think what's also important is, apart from looking at, okay, what's happening in the schools and the differentiation, and I don't want us to think of just the negative track, because again, I should emphasize there's been a lot of progress made, but we know that, there's still a lot of work to be done. So within the South African higher education landscape, we still have a number of challenges around access and high demand, of course, for higher education, which is good. It's good to have a high demand, but that comes with large numbers. So we have increased our enrollments, but the academic staff numbers have not increased to match those enrollments. And then there's inadequate funding generally for scholarships and fellowships in certain areas. We know that, we always have discussions around, every year we are worried about NSFAS and what are we going to do. And the reason I mention this is that when it comes to inclusion, and especially including students from spaces which might not be as privileged, the pipeline planning is important. And if we don't invest at even undergraduate level to make sure that there's proper skills training in the basic sciences, in the mathematics areas, physics areas, it becomes very difficult for us to increase the pool of masters and doctoral students. And then I think the other area, which is quite also important to consider here, is the issue around student success versus student access. So yes, students can come through the system, but the question is whether they finish, especially in the, and here I'm focusing on maths, of course, but I mean, one could extend this to engineering. I mean, people who do engineering, sometimes they finish, but the question is to ask whether they still work in those fields where they got the degree, or how are they applying that to the context, or are they able to find employment in other areas? And of course, then that brings us to the issue around unemployment, youth unemployment, poverty and inequality, which are the three big triple challenges for South Africa and the continent at large as well. And why I say this here is that we have seen trends in the last few years, especially in the higher education sector, where people even go up to PhD, they finish the doctorate, then they come as postdocs. And then they become what we call serial postdocs, because when the candidates can't find jobs, they keep on renewing the postdocs and changing university from one university to the other. And yet these are people with skills which are really needed for us in our economy to be able to innovate, to be able to contribute to society in one way or the other. And I think that's something important to think about as well. And then, of course, South Africa, amongst the African countries, has been really good at investing, I think, in terms of research and development, but we know that we have not reached over 1% of the GDP, and this is important, the growth. It's important for us to think about the importance of investment, of course, at national level in critical skills areas which are needed. And as you know now, I think with a change in the US, for example, around their policies, we were one of the countries that has been badly affected, for example, in terms of health research, the withdrawal funding, but we know that there's some good news in some sense that at least there are some the National Institute for Health, for example, and this position, recent communication in terms of, looking at South Africa favorably in terms of projects that involve clinical trials. And we've seen, I think, just last week as well, some rescinding decisions and also some partial funding for different projects, which looks better, but still it doesn't remove the threat that we face in terms of geopolitics and the impact on partnerships, fellowships, academic mobility, internationalization, and also research funding. So it means that as a sector, as universities, as researchers and people involved in these areas, we have to look broader than just relying on one country, but also thinking about our own context in terms of how we can sustain our enterprise in terms of research and training as well. And so having said that, then we know that the mathematical sciences are really foundational for innovation and problem solving in key sectors. And these words are used loosely. I mean, if you look at many documents, people use innovation, problem solving, but in actual sense, the mathematical sciences, in my view, contribute to all areas, whether it's the social sciences, engineering, manufacturing, health sciences. They play a big role because they don't just help us to solve problems that we are working on in our different disciplines, but they also help us to really think logically, to apply, for every context that we're given, to at least look at the information that's available, to think about, what does this information mean, and then to be able to interpret that. And if you look at the World Bank reports for 2022, you can see that there's also a big emphasis on skills gaps in science, technology, engineering, maths areas, where they do say that these are a limiting factor in achieving the developmental goals. And here, whenever I say developmental goals, of course, I mean the Sustainable Development Goals. There are 17 of them. So if you go to the United Nations website under SDGs, you'll find those. And each goal, of course, is explained in detail. And for those of you, you know that I always say, like for students and our researchers, encouraging everyone to apply for grants. If you're applying for grants, it's important to know about them, actually. I know that sometimes our maths colleagues don't like to have to look at too many other documents that might not be directly related to what we're doing. But these are important when you're applying for grants to articulate the projects within the Sustainable Development Goals and align them according to the funder, what they need. But it does help to make sure that at least your proposal can be seen favorably as well. And of course, within the South African context, I didn't mention here, there's a number of things which have happened in the last at least 5 years. We now have the Science, Technology, Innovation Decadal Plan, which is important again when you're applying for a grant. And we just recently had the NRF applications opening and closing. So when you're putting your proposals together to really make sure you have an idea of how these align. And then there is also the white paper on science, technology, and innovation, the 2019 paper, which also gives you a very good idea of how, what is the thinking nationally and what are the focus, the flagship programs which the country has as well. And then I think the other area which is highlighted as part of in the UNESCO report 2021 is this relationship between maths literacy and advanced mathematical reasoning, which are central to unlocking the fourth industrial technologies. Even though here I should argue that I think when I look at developments in places like China, where we had our students go there, I think about 2-3 weeks ago, I think we are no longer on 4IR. They are quite advanced in terms of technologies, and there's a lot that we can learn. And so as Africa, we need to think about, how we can leverage those technologies to improve both reinforcing the learning and teaching, and also, in terms of solving some of the challenges that we have around, renewable energy, climate, and what can be done in those areas. So having said that, according to the World Bank here, I should say that investing, this is a quotation verbatim from their report again, which says that investing in education from early childhood to lifelong time learning contributes to addressing equality and development. Education itself is seen as a human right. It's a powerful driver of development and one of the strongest instruments for reducing poverty, improving health, promoting gender equality, peace, resilience, and adaptation to climate change. It of course helps to deliver large, consistent returns in terms of income, and it is a critical factor to ensure equity and inclusion. And I say this here, I thought this quote was relevant, but I should also say that, of course, there are many other factors that play in when we talk about development. It doesn't help to have, for example, yes, we can invest in education, but if our systems, our governance systems, if there's corruption, if there's no accountability, then it won't help us to achieve the goals that we need to achieve. And I know engaging with some of our colleagues in a session we had yesterday, there are still schools and areas where you find that they don't still have the basics that are needed. And somebody was referring to the Eastern Cape areas, for example, where they are doing initiatives in schools where they try to make sure the schools have the basic facilities. But we know that it's not everybody who has that access. And then again, you see that one of the interesting things is that if you look at, so you know that the World Bank is, you might be wondering why the World Bank, there are other funders as well, but the World Bank invests a lot in education within Africa itself. And according to this November 2024 report, you can see that for so sub-Saharan Africa, the investment is close to 12.62 billion. And they also talk about the number of projects where they're investing. But this investment is always, of course, not enough because you do need also the country sort of to focus. That's why I mentioned the research development investment at national level, which is also important to think about in terms of the projects that are funded. But again, you can see even to have this data here, there are some mathematical skills which you need. Whoever puts these reports, you need statistical analysis which will come to play. You need to set up your models so that you're able to, predict what might happen and so forth. But this was just to show the investment in terms of education, in terms of the regions, sub-Saharan Africa. And then, as I mentioned earlier, that if you go to the United Nations website, you'll be able to get more details. But for education, the Sustainable Development Goal we look at is really the Sustainable Development Goal 4, which talks about ensuring inclusive and equitable quality education and promoting lifelong learning opportunities for all. And in that SDG, you see that, one of the objectives include progress towards quality education, which, is a focus. And of course, the impact of COVID-19 is usually never underestimated. Because it had an impact on education. In some areas, people were not able to continue normally because not everybody had access to, when you isolate people with the isolation policy, not everyone had access to, online learning and so forth. And then there's also issues around additional measures which were needed to, to ensure that children and young people are kept in school rather than out of school. And then, of course, education is seen as a key in terms of really making sure we reduce inequalities to reach gender equality. And then you see there the targets. If you just look at the population, in 2015, there were 109 million children in school. And then in 2023, of course, there was an estimated 272 million still out of school. And so you can see that there's still some challenges, progress made, but this is still a big challenge in terms of access to education. So let's look at a bit of some country profile data. So this is the percentage of students in the natural sciences, maths, and statistics. And again, you can see here, and unfortunately, this one doesn't include South Africa, but I kind of ticked on the G20 and the other countries which are shown. And you can see here that France actually here has the highest percentage of students according to this data. This data is from, if I'm correct, it was 2022 field data. So you can see that France has a lot of students enrolled. And then if I look at, and then you can see the other countries there. But of course, what might be useful is to look at, and you can check these data fields yourself. If you go to the OECD website, you can actually change the fields. You can also choose which countries to compare. But the challenge here again, which I think also provides a good opportunity for the African scientists, especially in the mathematical statistical sciences, is that there's a lot of data sets for Africa which are not really available. In some places, there's no data available, and some data I think might not exactly be accurate. So you can see already, like from your side, if you're doing anything around, statistical analysis and so forth, it's a good data set to look at. But the point here is that the reason I was showing that graph is that if you look at France and its economic development, you see that it does better, but I think part of it is the investment in the STEM areas as well. And if you look at the discussions currently which are taking place on, is it military arms with the Americans and the EU, France has a big role to play in terms of that, because I think they also have the capacity to produce a lot. Even though technology, we know that must always use for good. We are just not talking about military weapons and the, what is the latest technology in place, but we want to develop technology for human development and not for killing people and so forth. Yeah, but then for security reasons and so forth, you do need investment in those areas as well. And this graph shows, and you can see, I don't know if you can see that, I just need to move that away so that you can see the enrollment rate in early childhood education, because as I mentioned earlier, that you see that from the research that has been done, there's an expected correlation between investing in early childhood education and then performance later in higher education. And you can see here in terms of South Korea, they have a higher percentage. And then unfortunately here I could not see France, and I don't know why it didn't appear on this list. But I assume the other countries which don't appear here maybe the data was not available for this report, because I could only get up to Switzerland, but I couldn't get data for United States, Belgium, and Canada as well. But what's important is, again, if you look at South Korea, it will tell you a lot about their education system, especially in maths and science, which I think makes a big difference. And then what's the other one? Sorry, I have to try and move my slide. No? Okay. Yeah. And then here, this indicator really is youth not in employment, education, or training, which refers to the share of young people who are not engaged in any form of employment, formal education, or training. And in this case, you see that the highest percentage, according to this 2023 report, shows that Turkey, for example, has the highest percentage of youth not in employment or education, and then followed by those countries that are listed. And France, of course, appears back here because it was leading in the other list. I think that's why I was trying to mention. It also has a percentage not employed, and I think this talks to translation as well. But if you know our unemployment rate in South Africa, you understand that we still have a very high unemployment rate amongst youth. The last time I checked, we're still around over 60% of our youth unemployed. But we also know that if people have a degree, they have a better chance of being employed. But we can't, and when I say this is based on the data, but I don't think we have data that shows exactly what that percentage is in terms of the country profile itself. So there's a lot of opportunity, again, of thinking about solutions which can also help to track graduates' employability. There are many people are developing apps. I know that through Stellenbosch University, we have the Launch Lab, for example, which works with a lot of young entrepreneurs and students from engineering and other fields who are developing apps for different applications, which also opens up opportunities for innovation as well. So some of the recommendations made here then from this data set is that it's important to align the mathematical science training with national science technology innovation priorities. And within the context where we are in South Africa, we know that energy area, climate is also an issue, health, and then AI and technologies which are needed to increase equality. So we know that usually with technology, some communities will benefit more than others. But if we can think of how to leverage and how we can, help to solve solutions within our respective communities to help people who would not normally have access to, what other people have, that could open up opportunities for creating new jobs and also new areas where maths, the benefit of doing maths can be seen. And I think that's where we struggle, because often when we write, for grants, and even when we're asked about impact reports for maths, I think most of the maths colleagues will complain that, but I don't think my maths has an impact because I'm just doing, I'm doing graph theory, I am doing pure maths, so there's no impact. But actually there is impact, because if you think about the skills training, we are contributing to creating jobs. If our students finish doing maths and they work in a bank or they stay in the university as an academic, we are still contributing to the employment targets of the country, which contribute inevitably to development, but also to solutions. I mean, in any of these fields, the energy area, and I must say energy, renewable energy, we haven't, so there's still maths which needs to be developed to be able to be applied to these areas, so that, to develop these methodologies so that people know which methodologies do I use if I'm working in this area. We always emphasize collaboration between the different fields, but what we don't have is a set of tools that can guide people in terms of how do I do interdisciplinary research and what methodologies can I use in this area. And in the curriculum, how do we introduce students to methods which can be used in these interdisciplinary spaces that are sort of formalized and not learn on the go as you go along. I get a lot of these questions around if I have to work with people, let's say let's say I've done maths, I want to work with people in health or climate, what maths must I do to get into that field? And that's a question which one says, well, we still have the general maths curricula, but we haven't really designed these interdisciplinary sort of curricula that help people to interface with the different fields. And then the other thing is that because we are in the university sector, it's important for us to strengthen our partnerships, exactly because it would help our graduates to learn the interdisciplinary skills, inter or transdisciplinary skills as well, because partnerships with business industries and other sectors will help us to understand what are the challenges that these industries or businesses or communities have, and how do we design our research projects around that to be able to address those challenges that they have. But this does not replace the need to know the subject well enough in terms of the discipline and methodologies so that you can apply to other fields. It's not so easy to apply something that you may not have the depth of understanding in. So my view is that it doesn't replace the need for basic science, for understanding the foundational theories in your respective field, so that if you understand them well enough, you can apply them to other scenarios as well, in collaboration with the partners that you may find along the way. And then developing post-school opportunities, including community adult learning and mathematical and quantitative skills through institutions of higher learning is important. And not many of us, I must admit, like have even night school for people who may just want to do something interesting in our university that gives them a skill that helps them with just mathematical thinking, or doing something interesting around, coding for people, who may be, who are not regular students, for example, in our communities. So we talk about, us trying to be relevant within our community or society, but I think we don't have a lot of programs that help people who have already gone to school and are now interested in helping or engaging with the university at other levels. So of course, we have a lot of work to get our youth on track, but I think it's something we have to think about, programs beyond just the usual programs that we offer in partnership with our partners as well. So I think here what I want to do, and if you have questions, again, you can ask, but what I want to do here is talk a little bit about the skills, future skills, which are needed for the future, what we call 21st century skills. And you find there is a number of reports. I just didn't have time to look at the various reports that are available, but I know that I've seen a number of reports where they've done skills mapping for South Africa, and then also for where they also look at, there's an organization, I think it's which looks at the skills gap within our system, but I didn't want to limit myself to that. So I will share these ones with you. And in this case, skills for the future, when we think about, you see here from the World Bank report again, it talks about foundational and higher order cognitive skills. And for me already, this says that actually mathematics contributes to exactly this, the foundation and higher order cognitive skills, literacy and numeracy, which are basic skills that are needed, critical thinking and problem solving. In whichever environment you're in, the maths helps you to do that. And I used to wonder, like in my case, I did maths, I never did management. I mean, I never thought that I would have to manage anything, actually, when I was doing maths. I just did it because I loved it. And then at some point when I look at where I am now, every single day I have to use, I think, bullet 1, 2, actually most of these here. The literacy and numeracy helps me, at least it also helps me to understand, what's going on. Critical thinking and problem solving, these happen and they are not the same. Every day you have to think about, you get new situations which you have to deal with. Communication, information analysis, reasoning and adaptability, and learning from experience. And I think here experience for me, I think for the maths, especially our maths candidates who are doing different things, like your master's, doctoral candidates, or even honors students. What's important here is that, so having exposure and also having chances where you can present, whether it's a local conference, international conference, or even, during vacations, some summer schools or whatever it is, meeting other people helps you to learn skills that you can't actually learn from your program itself, because in your program, you're really focusing on the problem that you're working on. So these other skills come through interactions as well with other people and communities, and it also helps you to network. So I think that's important for us to also think about in terms of, possible skills that one can learn, but these are critical for anyone who's trying to go into the world and do something, whether it's the world of work. And then the other part is social and emotional skills. And can you get that from maths? I think you can, but maybe it's not very visible. So I think, again, here you see that the focus here is around future skills. Even though they're called future skills, I believe the future has come already, actually. Emotional intelligence and self-control is important. Relationship management, teamwork and collaboration, leadership. And then I think maths helps you with grit and resilience. Because despite what people say, I think maths is hard. It is hard, of course. It becomes harder as you probably go higher. At some point, it's easy and routine, but I mean, it is hard. It requires time. It requires resilience. There are moments where you just feel, oh God, everything failed, but then you keep on trying. So it gives you grit and resilience. And I think grit and resilience is a critical skill which is needed for success, because even when we talk about things like, you know, you hear a lot of people talking today about entrepreneurship. We must make sure our students are employable. We must make sure our students can do ABCD. But all of that also requires a lot of rigor, a lot of, you know, trying and sometimes failing, of course. But grit and resilience is important for any situation that you find yourself in, even real life situations where it could be with your relationships and other things that you have to deal with. But working with people, team collaboration, and again, here navigating social situations and cultural situations. We all find ourselves in different spaces where the culture and may be different, and exposing yourself to other, you know, environments is so important. And that's why I believe that as an organization or even universities, having a little bit of funding for postgraduate exposure for conferences, meetings, workshops, in whichever form, can play a critical role in terms of, you know, enhancing those skills. And then lastly, I think the third area is really around specialized skills, which, you know, would involve technical expertise. And in this case, remember I mentioned earlier that to do interdisciplinary research, to do transdisciplinary research involves, of course, more than just the university or other disciplines. That means when you're working with communities, industries, and other people, you do need to have very strong foundational skills in your field to understand them well enough so that when you're given a different scenario, you can apply those to those scenarios as well. So recently, I think I'm just looking at the number of projects that we are doing. You know, you learn a lot actually working with other people. I know in the health sciences, there's a lot of data and research also, which we are working with. And I'm interested in two areas currently, which look at, of course, cancer research. And I've asked some colleagues who are based in the US as well to help us with some data, which we can, you know, access. It's not so easy to access data in certain areas, but very interesting work happening there. And then there's some groups which are doing really interesting work also around, you know, climate models. And even there, the question has been around, you know, we have this situation, you know, what maths can help us to actually develop some consistent sort of methodologies to deal with this data. So we are working with these groups trying to understand what's happening. So I think technical expertise is very important in any case. You can't replace it by anything else. You have to just do it until you master it and apply it to different situations. And then industry-specific knowledge, tool and technology mastery. This is skills for the future, of course. But as I said, the future is here, advanced cognitive skills, and then entrepreneurial thinking. And most of these skills, again, you'll not get them by just doing your research project, but some kind of exposure even to the industry scenario for those of you who plan to go in the industry. And then I know some colleagues want to become academics. If you're following the academic track or researcher track, then of course the needs will be slightly different. And then the other part of skills, cross-cutting skills, is really digital skills. And these ones we know, and you know, as you know, you can't run away from this one. Accessing and managing digital information, digital communication, evaluating and integrating digital content, creating and sharing content responsibly, cyber safety and security, but also digital ethics as well, which have to be taken into account. And here you can see computer science students, coding skills are important, software design, which helps you to design solutions, because if you can actually do software design, you can actually help people to address the processes in whichever scenario they are in a different way. You can actually help to design solutions which they can use to make their processes, you know, much faster, much easier. And it is, and you can see again, the mathematical sciences play a big role in these areas. And these are areas which benefit people. So as mathematicians, we impact people. We actually are helping people to think for themselves, to design solutions which help them as well. So I think that was important to mention. And then, of course, just because I did mention at the beginning that the abstract that was sent and the title is slightly different. So here I just wanted to mention quickly that so the work I do is based really on differential equations, but we know that differential equations can have many applications in different fields, mostly in the natural and engineering areas. And you can apply them in terms of the models that you analyze. Each model can be written in an expression, of course, which we call a differential equation. And there are different types of equations that come up. Some are easy to analyze and find solutions. Some are not. And then we have different methods that one can use. And so the method that I talk about usually is the symmetry methods and Lie groups. And it's just one of the methods that can be used. It's not the only method. So, but with this method, instead of guessing, like, so if you're given a nonlinear system, then I have to guess what transformation will help me to move from this system to a linear one. So instead of guessing, this method helps you to find a formal way of finding these transformations, which will help you move from a nonlinear system to a linear one, which you can probably solve, easier to solve. But also, they formalize the method, and then the applications are huge. In physics, for example, we talk about invariance, first integrals and so forth. And then you can also apply those methods to many areas. And you see there's a lot of publications recently. And I just think every day there's a journal that is trying to do something. And I think you have to be aware of the MDPI, because I don't know. I might be wrong, but I mean, I get papers from them every 2 days, which is weird. And sometimes I don't have time to respond. Then they'll write after 7 days and say, you didn't respond, hence we are allocating this review to someone else. But even before you respond, they do that. But anyway, so it could be just isolated incidents, but you have to be aware of a lot of journals which seem to be a bit, I suspect, predatory. But you just need to look out for those. But in any case, you find a lot of applications for differential equations, which we are looking at as well. I've got a team of people that I'm working with currently, because I usually don't get time to do all the technical details in terms of, trying to use Mathematica to work out all the technical details. So I have some students who are helping and some postdocs as well. But the point is that there's always something to do. But the question I always ask is, so why are we doing this? Who's the beneficiary? So I would like to, maybe if you're interested in the area, you can just email us. We're interested to collaborate. I have to say here, I just wanted to show a little bit of what we're doing at Stellenbosch University to promote the mathematical and computational sciences. And then also, if any of you, our researchers who are on this group, or even if you're interested in collaborating, we are very open to collaboration. But also, I did show you the workshop which is taking place in November, which I would like you to, if you're available, it's local, so it's cheaper, and also it gives you an opportunity to connect with other people as well. You are welcome to send your abstract and join us as well. So what are we doing at the university? So through transformative partnerships, we believe that collaboration is power. We are concerned about the curricula. We would like it to be innovative. We are promoting joint degrees and supervision through partnerships that we have. I know that currently one of such an innovative sort of partnership has been done with an international university, where we have joint PhD candidates and focusing on computational astronomy at the moment. But there are other areas as well where we are driving these joint degrees, and we want to develop more of these across the the sector, and would like some local collaborations as well around joint degrees. I've not heard of a single joint degree with a local university, and yet we all are working towards the same goals, and I think that's something which would be interesting to have. We believe that as institutions, higher education institutions, and I know for Stellenbosch, we want to be anchored within the local, regional, national, and continental landscape, and we want to be able to deal with not just global challenges, but also our local challenges so that we have societal impact in terms of our solutions. And we believe we can do this from all disciplines, not just mathematics, and it's not just the other areas, but to think about how can we contribute to the developmental goals of our regions, respective regions. And then equity and inclusion is important for us. It's something that in everything that we do, we want to make sure that that's part of our ethos and our practice as well. And then knowledge co-creation to encourage research, teaching, and learning that integrates diverse perspectives from communities, industries, and experts. And for those of you who are already, I know there are many of you, some of you who are already involved in projects which help communities, but and projects which are probably informing these different spaces as well. So to encourage you that, if you can think about where do you see yourself 5 years from now, and I speak here really to if there are any postgraduate students, to think about what impact do you want to make. I mean, you do maths, you're going to get a degree, or you already have a degree, but how are you helping others as well in your space? I think a focus on impact is important and something for you to think about. And then innovative institutional culture and change, trying to create an enabling environment for participation, creativity and innovation, where voice, power, and position do not limit participation. We believe that people should not feel that because I came from a university which is not as resourceful that I can't participate in this or that, but also it should not depend on the status that a person has for them to participate. So we really want a culture which is inclusive. I think this is what it's trying to say, and inclusive and enabling for everybody, because we believe solutions can come from anywhere. Actually, even people who have not had a better experience can contribute. So, and then here I just wanted to mention that, so what we've done also at Stellenbosch is that we've linked up with the Ludwig Maximilian University in Munich to match researchers in different disciplines. So in this workshop, which we held in February, we brought people from mathematics, health, physiological sciences, computation, astronomy, physics, social sciences to engage on areas of interest. And we've followed up on this by putting a seed grant, which involves both the University of Stellenbosch staff members and the LMU staff members, just to encourage some collaboration. Again, the emphasis is bringing teams together to try and collaborate. And then through the department, our science faculty, we do quite a bit there at the Department of Mathematical Sciences and the African Institute for Mathematical Sciences. With our partners, we contribute, just like the other universities also in the region, to train students at master's and doctoral level, and also get involved in outreach programs with schools. And I know that the CoE and other institutions are also involved in that. And then we're also promoting interdisciplinarity through a number of initiatives that include our 2 schools. So we've set up these schools because we think that the schools will probably take us where we want to go in terms of interdisciplinary research. So the School for Climate Studies, for example, brings a number of researchers, world-class researchers together. And we are focusing on really driving, we want more students to come into this area. So part of our focus now is to try to design a program for climate studies that can allow people to, register in that program and then, at least get a degree, but also do interesting problems. There are many practitioners who ask us, do you have a PhD in climate studies? What can we do? So, but I believe that even in this area, there's an opportunity to, to actually design the mathematical content around what skills are needed. So what maths content is needed for you to deal with climate modeling types of problems for the people and practitioners who are who are interested in this area. And then the other school that we've set up, and I know that other universities also have these focus areas in any case, is the School for Data Science and Computational Thinking, which is also a big game changer for us. And we believe that through these schools, when I say believe, we've done quite a bit. I mean, if you look at the School for Data Science and Computational Thinking, and I'll show you just now, is we have a Center for Epidemic and Response. And that center was responsible for sequencing the Omicron virus for COVID-19, which you know about already. But that was done through the Data Science Center. And they deal with a lot of big data. And I think I've spoken to also a number of colleagues who are doing work within the school itself, who talk about, you know, like they have a lot of data, but they need people to like, you know, what do they do with this data? Is there somebody who can help them with modeling the data that they have, that they collect? And it's data over, you know, many, many years, and lots of it in different forms. So I think there's opportunities there for the data scientists to think about as well. And so I talked about the data school again, just to go into details. There you see that we have the Center for Epidemic Response and Innovation, which does genomic surveillance. Again, lots of data there and opportunities for collaboration. Then most of you will also know through the CoE-MaSS that there's also the National Institute for Theoretical and Computational Sciences, which is a Department of Science Innovation, NRF initiative. And here all universities are actually involved. And you can see this platform helps us to advance theoretical physics, quantum computing, and data science through you know, the 24 university consortiums. I think now it's all the 26. And then there's the South African Center for Epidemiological Modeling and Analysis, again, SACIMA, which has done a lot of work in the past around modeling for public health, HIV, TB, and other diseases. And again, here, I do see lots of potential for, you know, for one to think about, you know, what problems would you like to apply the maths to as well, or ways maths used. I mean, it's used in that area. SACIMA does quite a bit in terms of mathematical modeling. And then recently we set up an innovation lab. This one works with the Office of the Presidency. And basically we use data science to inform and shape real-time policy through collaboration with the government and NGOs. And you can see again here, so it's a group of people coming together and saying to government, you know, you have a lot of things that you're doing. How can we show you the impact based on real-time data? And I think that is co-funded by the presidents as well, which I think is critical. And the other thing I think which I feel is important is when you talk about capacity building, so you can see our capacity building not just for Stellenbosch, not just for South Africa, but also extended to the continent. So through the Center for Epidemic Response, for example, and working with the Mastercard Foundation, we recently got awarded this African Stars Fellowship Program, which hosts 131 fellows, which will be funded over 3 years. And in this, 60% of the fellows have to be women. You know, the Mastercard Foundation really focuses also on gender. They have to be women, and it includes, you know, doing 2 structured masters in the healthcare leadership and also in pathogen genomics and bioinformatics. And you can see already in bioinformatics, we do use, you know, maths, the mathematical sciences, and also statistics quite a lot there. And here, I think it's the same. You know, I talked about SACIMA, what they're doing. I did mention the Policy Innovation Hub, what they're doing. And the Policy Innovation Hub, just to say, is also, you know, the presidency is involved through the partnership, the German government, and then the Bill Melinda Gates Foundation, which funds that. And then you know about NIFEX already. So let me talk a bit about the School for Climate Studies, a transdisciplinary hub for climate solutions. And here we are also we're interested in partnering, not just locally, but also internationally as well. So here we really look at, you know, climate science, policy, technology, and development. And then it works across all the 10 different disciplines that we have. We have 10 faculties at the university, so it's all disciplines. And we also engage with government, industry, and civil society, including the Western Cape government, which has also been very interested around climate impacts. And so we have a joint, you know, platform where we talk about these things as well with them. And then So having said that, mathematical methods for systematically and holistically dealing with new interdisciplinary emerging areas, as I mentioned, in climate modeling, health, have not been developed in their fullness and rigor, and provide a great opportunity for new research areas for applied mathematicians and computer scientists. I can say this confidently because I know that there's been a lot of interest in terms of, trying to find how can we work with colleagues in other fields to make sure that we have some formal, curricula, formal methods that can help for people working in these spaces as part of the training so that they're equipped. And so this is just a word cloud of all the areas that we are involved in currently. When I say we, I don't mean myself as a person, but where people are doing different stuff, which also involves, having mathematical skills which can help you to measure measurements in these areas, invasion, biology, there's water, food. So you can see data science, applied data science, climate change. So this is just to show you, but this, of course, this sample is based on Stellenbosch, but you can do this mapping for any other environment that you find yourself in. And I think before I see the time is not on my side, but in any case, the other thing I wanted to mention, and because we have younger scholars here, is some of you will end up in university. Some of you who are not already in university, working environments might end up in industry. Some of you might, be looking for something. But so I always put in this slide around innovation and collaboration, which I think is important, is that so we push a lot the agenda of trying to work across, thinking about options that one can have in life other than becoming a super postdoc fellow, changing postdocs until, forever, but trying to really enable and empower researchers to think about other pathways as a mathematician. What can you do that is different from, not only different, that can at least give you something to focus on that can make a contribution. So thinking about entrepreneurship is key. And when we talk about being collaborative, understanding who can help you to develop your idea so that you can actually start up something, whether it's a consultancy, whether it's an innovation that you're producing, whether you've come up with a solution through your AI apps, other apps that you may come up with. So basically, this slide is really to encourage creativity and entrepreneurial behavior. Don't be closed to other ideas that are possible, promoting interaction with industry, research, consultation, and establishment of new businesses. How do I establish a new business for or an NGO where you may want to help others, because that's also possible. Expanding initiatives which focus on knowledge exchange, and then encouraging research translation as part of the research agenda. So at Stellenbosch, I know there are two entities that we use currently, Launch Lab and Innovus. Innovus does our tech transfer stuff. And then the Launch Lab helps with developing entrepreneurs and also helping you to develop the business ideas, startups. And I know through the Entrepreneurial Development Higher Education Program that these are available perhaps in all universities. You have one form or the other. So, but I think for maths students, I did meet one or two maths students who are doing something interesting this year. But I usually find that it's always students from other disciplines and not traditionally maths, and there must be a reason for that. I've seen engineering students because, of course, the type of projects help to kind of start something new. But there's no reason why I think our maths fellows also can't be involved. So these are just examples of some of the companies that have many, of course, from the biotechnology area and health area. But again, I can assure you that to do some of this work, you can't do it if your maths was not, good, if it was not good, and if you didn't get exposure to it. And then, of course, lastly, I think I will probably stop soon, is the Africa-Europe clusters of research excellence, which I think here what we try to do is really to focus, and there are a number of universities in South Africa involved, including WITS itself. And so we have 4 areas where we, again, as I mentioned, where we are using, you can see the way they are pitched, that they they are interdisciplinary. There's one area, of course, which involved NETHEX, which is around addressing global and African challenges through methods from artificial intelligence, data science, and theoretical and computational thinking. And then there's another area on genomics for health, and then an area on nature-based solutions. You can see that's climate, there's health, there's AI and computational thinking, there's theoretical and computational thinking, and then renewable energy. And in renewable energy, there's also like an area where some of the colleagues we've been interacting with in this area, where they talk about, of course, models, they deal with modeling, and you do need mathematical skills to work in these areas, but these provide a great opportunity for collaboration. And here it was just the facilities where we encourage different researchers to come. So I think I'll stop here for now, if it's okay to the program director. And then, because I see the time is 11:33. And then, yeah, just to thank you once again. And I'm sorry that the abstract might not have mentioned, the title and the abstract actually were two different things. Yeah, so, but I could take questions at this point, if that's okay, to the program director. Thank you.
Thank you for a very interesting presentation on the higher education landscape and developmental landscape of Africa research-wise. It's rather sad that math sciences didn't make it into the STIs. They somewhat undermined the STI priorities and the appear in artificial intelligence. But they underpin every one of them. And I would like to ask for questions. Are there questions in the chat? Okay.
I see Professor Yasak. Professor Yasak has a question.
Yes.
Hi, Sibu.
Hello,
Good to
how are
hear
you?
Good. I mean, I have rather a comment, maybe strengthening one of your points about journals. Just the number of new journals is exploding at this moment, and especially young researchers should be very careful to select proper platforms to publish their research. And then the point is that these journals quite often are very flattering. They write to you, we have just read about your great research, something like that. Would you care to write an article? It is just $4,000 per publication. We can give you 50% discount, something like that. So yeah, just to reinforce your point, beware of publishers like MDPI, Frontiers, things like that. It's quite dangerous.
But thank you so much for that. Yes, I think also the other thing, what I noticed is that, so, as universities, we, for example, the postdocs, we say to them, they must publish so many per year, right? So when they're desperate and such an email comes, they will just go for it. So yeah, there's a lot. I don't even know what is the best way of, maybe we need to emphasize this quite a lot in our areas, and also maybe in the university itself, to discourage people from just submitting, also checking with the senior professors in the areas for advice at least, right? Rather than come back later and say, you know what, I sent to this journal, but I just discovered that it's a ripoff. And then conferences. The other thing is conferences. How do I know which conference to attend? We were called with, we got a grant from the US some years ago with a lady who was working at, I think, one of the Canadian universities. And we got a letter to say, come to Cambridge University, blah, blah, blah. It was very well written and sponsored, by the way, by this US agency. And when we reached there, I realized after some time that something is wrong. All the fields were there, all the fields.
Yeah.
It wasn't maths, it was everything. And I think it's just, so one needs to be really vigilant. And I think we have to, I don't know, even around conferences, what conference makes sense? It's also an area which needs to be, I think these are things which people need to be made aware of as well.
Yeah, I mean, just for conferences, just have a look who is attending, who is on the board. And in some sense, with the current system of subsidies, still, I mean, from the university point of view, paying $4,000 per publication is still actually a very good investment. Yes, because it's just 80,000 runs, and I think you get, you know, in return 140 or something like that. So
yeah, 120 plus 127, I think it's around
yeah, something
there.
like that. So it's still 50%, you know, return. Great business.
Yeah,
Okay,
yeah. So I think,
yeah.
but I think the CoE-MaSS can also help us in terms of this, you know, like always having like some ideas of, okay, these are good conferences. Well, I know that you can get into trouble sometimes because some people say, how did you know we were bad and whatnot? So maybe the CoE-MaSS can help us.
Okay, thanks. I don't want to monopolize the discussion.
No problem. Thank you. Thank you.
There are even some entirely fraudulent conferences now that are advertised. So one has to be aware that there are conferences which are entirely fake that are advertised on the internet. I know about a year ago when academic registered for air tickets, everyone paid the money and got there and there's no conference. The whole thing was money laundering.
Oh, yeah, that's scary. But that's why we need the computer scientists, to develop something that can help us. An AI too, which can tell me this is fake, this is not.
Exactly. Prof. Mason.
This was a very interesting presentation. Just a sort of comment. We organized the Mass and Industry Study Group in January each year, and that's a good example of teamwork, which you were emphasizing, leadership skills, leading people getting skills in leading little research groups, teamwork and collaboration, and industry-specific knowledge. And another important aspect of National Industry Study Group is grit and resilience. Mathematicians sometimes are given a difficult problem to solve, and they, instead of solving that, they solve something else, and the contribution there, but that's no use in industry. If you tell them, they ask you to solve a problem and you go back and say we solve something else, that's not acceptable.
That's interesting. Professor Mason, thank you so much for that. And it's a good example. Yeah, I actually did it. I forgot to mention that because this is a very good example of how you kind of facilitate the discussions with different pairs. But you're right about solving different problems. We always have this problem, and I've seen it when we are doing applied problems with other, disciplines. So if it is a hard problem, then somebody says, no, I'll change this parameter, and then it becomes something else. And then you go back, but it's not the problem that they had in the beginning. Yeah, but you're right about that. Thank you so much for those comments, and hope we can collaborate as well going forward. I would like our students maybe to get some exposure. I know they come maybe through the CoE-MaSS, but obviously for 2026, maybe we can reach out, Prof. Mason, in terms of seeing how we can get more of our students involved in the mass industry strategy group.
Very much.
Sure. This is a comment to get around Prof. Mason's situation is you should be able to convince industry that this is actually what they need to know that which you can solve.
Anna.
That's a good one.
All right.
Thank you so much.
Good morning, everyone. I'm Anna Kaduma from Statistics University. I just wanted to share with everyone that beginning of this year, thanks to generous donation by the CoE, we were able to host jointly with UP what we call a data fest in statistics, of course, originating from the American Statistical Association. They have this going for a number of years now. You can register there and your students get to deal with data together with students all over the world, solving real world problems from real world institutions. Were very generous to donate their data. We had about 15 students this year, because starting small, this is something that's been done the first in South Africa this year. The enthusiasm we saw in the students after they dealt with real data was, phenomenal. They really appreciated the fact that they got to deal with real data, got to apply what they learned in class to see what it is, what it means to solve problems statistically using, the methodology they know. It is what we call a hackathon, 2-day event, very high speed, high intense. They do presentations. And I think if we have some things like these planned around ourselves in South Africa as well, convincing industry to give us data, it would be a good exposure to our students to know exactly what they need to do when they go out there. We involved honors and master's students worldwide, or Americans involved mostly undergrads. But it was such a good time, or a good way of students to see how they apply their knowledge. And I think some of the comments we got back was this was a way for them to see how to go out there and actually do their work immediately. So I would like to encourage maybe, CoE and someone else to give us continuous funding, if you will, and if we could expand some projects like this to just get our students involved in what it means to use mathematics, mathematical sciences, or different areas to solve problems in the world. Thank you.
Thank you so much, Anna. I think that's a very important comment. And so I think also maybe to think about scaling. I know you are starting with 15, but also think about, how do you create an ecosystem amongst the universities, through the CoE, because obviously we are all connected to the CoE, to kind of, bring different parties together, because I do believe hackathons are good. I know some business schools, I know that there's one, at least a French business school, where they also use, but they have to get agreements with companies to give the students real data, which they use for, AI and data science, for the data science program. So the students work with the real data from these companies, but of course you need to have agreements in place, because some companies don't want you to, share the data widely, and so forth. Yeah, but it's a very good idea. Yeah, thank you.
Thank you so much. Yeah.
Thank you.
Thanks, Prof, for the interesting talk and the landscape. But I mean, thinking about what Prof mentioned was talking about in terms of industry. I like the examples you gave. I'm Farai, by the way, from the business school, also but look, the application of medicine, stats, and health, etc. Those are very well pronounced from the point of view, I believe, like the examples you're giving. But what I find to be a place where we're lagging behind, particularly in an African context, is actually the face of industry at our universities, which is a business school setup. If you look overseas, you notice that there's a lot of programs and research institutes that are based in business, which apply, your typical math, stats, and computing to real industry problems, like Prof was talking about. But in an African context, you notice that we don't have such. So even in the examples that we show in Prof, with all respects, I didn't see Stellenbosch Business School there. So is there something you could talk about there? Because that's my observation, having also moved from a mathematical or statistics department recently, business school. It's something that I'm actually doing.
And you're right about that, right? Thanks for your question. You are so I must declare that I didn't mention the business school, not because they are not doing anything, but as you know, I'll make a general comment, and it's not related to Stellenbosch really, but in general, this was my observation, and I don't know if this has changed. So most people who do in the social sciences, and I think especially in the management sciences, they tended to, in what I knew up to a certain point when we're doing the doctoral reviews, is that people tended to contract out the statistical analysis part. I don't know if you understand that. So it's as if I am doing the degree, and there are many people, by the way, who've become very rich from actually helping people to analyze the data which they collect. And in some cases, we found that actually sometimes people don't even know what data they need. They contract the whole sort of analytics part to someone else. which is probably not, and that can explain why we have a lot of issues around people taking, 6, 7 years to finish a PhD, because they contract the work out. And then if you are lucky, if you get someone good, they will finish that degree, and you don't know who actually owns the degree. Is it the person who's doing the degree, or is it the contractor who actually was paid to do the analytics? So I won't go into details into that, but I just think there's a big gap, as you say. I think that, as I mentioned just now, the example I was giving is actually at a business school where they do analytics themselves. The students are involved deeply in that, and it's a business school. Nothing stops us from having that. And I think, Farah, your role there is as a person who's coming in from the statistics department is to really influence the curricula itself in terms of what do people do as part of their program. And that does take time, as you know. You have to negotiate spaces, because people will tell you, we've been doing this for so many years and we are doing great and we are one of the best schools. So you have to actually negotiate how you can bring that, I think, through the projects that you do yourself, and then you can use that to build up the curricula as well in the long run. So I would say that, yeah, there is work to do, and I agree with you. I won't say that it's not true. Yeah.
Thank you.
Sorry.
Is there a question in the chat? Thank you for a very interesting presentation, with lots of questions and good debate. And we hope that it has spurred some interest for the audience to get in contact with you. And an interesting look at South African framework of mathematical sciences. And we hope that we get a little bit more than 1% R&D in South Africa in the future. Thank you.